Hello and welcome to this lecture on GCP infrastructure. What we are going to see in this lecture is an introduction to identity and access management, which is the key for any cloud service or anyone who is trying to use a cloud service. Then we are going to see a demo of the web console, and then we'll see about what are the resources available in GCP or the features of GCP which we are going to use as part of our DevOps course. Let's see what's happening behind the scenes in GCP. So this is a very high level view of any cloud service, actually, not only GCP. So if you look at that diagram, it may be missing some of the features, but this is kind of a very high level view. So if you look at the diagram, so the base level, so bottom level is the bare metal, which is like the infrastructure which is there, and then on top of that comes the compute, and on top of that comes the resources and other features which GCP provides. For example, the compute engine, app engine, GKE, load balancer, VPC, everything that comes up above that. And we'll be able to access this through web console, which is developed on top of the SDK. The SDK has the ability to provide APIs for all the resources and features which is below that, and the same SDK can be used by any infrastructure as code tools like Terraform or Ansible to manage the cloud resources and features. They also have other clients which can use the SDK. For example, like you can use Python. There's a SDK available for Python with GCP which can be used, and also the G-Cloud command line uses the SDK behind the scene. So that's how the GCP is structured from ground above, from the bare metal to above. On both sides you can see like security is there in all the level and audit is there in all the levels, and I don't want to go in depth beyond this into the behind the scenes of GCP, because you can have a separate chapter just for this. So let's actually go to the next slide on identity and access management. So identity and access management is the basic for any cloud service or any organization go in. You will be provided with an email ID or identity, and then you will be a part of a group, and you'll be a member of a group. So like that, identity and access management is defined as follows in GCP. First thing, a unit which is called the policy contains one or more members, and members are like, they can be any of these following. So it can be a Google account, so any gmail.com account. It can be a Google group, and it can be a service account. I'll come to the service account later when we actually go through the IAM console. And next is cloud identity and G Suite. So if you look at all these, actually usually like people don't go with Google account or Google group accounts, because that's something more public, which public email IDs, which is not secure. So if you go in a corporate environment, they'll usually use G Suite or cloud identity. So it will be like your email ID at your company name or company email ID.com that will be used. Service accounts are accounts used for service to service access. So service to service means either from one of your tools which you are using, for example like the G-Cloud command line or infrastructure as a code tools like Terraform. They use service accounts to access the feature and then manage the cloud in GCP. And if you look at the cloud identity, which is like your email ID, so you'll be given certain responsibilities, certain roles So each member has one or more roles. I'll quickly take you through the roles when we take a look at the console. Then the roles control access to resources. So resources are GCP APIs and features which you'll be seeing in the web console. Here is a quick example of what a policy is. For example, if DevOps team policy, like I can have a person in my company like john.doe@amazon.cloud, or a group DevOps-group at amazon.cloud, which is being connected to GCP via cloud identity, or I've been using G Suite for managing my entire fleet of employees, and I'll be given different roles. So for example, like I'll be giving different roles for the DevOps team, which are like cloud build editor, Kubernetes engine, cluster admin, app engine code viewer. We'll see more about the roles later in the consecutive lectures as we go through different resources and features. And resources are nothing but cloud build, GKE, app engine. These are all the features available from Google Cloud. Let's see what the GKE Web Console is and how it looks like. I have actually two views here. One is a corporate view where an organization is configured, and if you go back to the previous slide, you can see like where the cloud identity or G Suite being used. That's where you'll get an organization attached to your Google Cloud account. And another one which I used where I actually signed up using a Gmail account or another email ID which is not attached to any of the cloud identity or G Suite. So there's a small difference between both of them. We'll see what it is in the console. Okay, I am now logged into the Google Cloud Platform Web Console. So I can see my dashboard over there. On top, you'll have a search bar where you can actually search through different features and resources available in GCP. On the right hand side, you can see like you can activate the Cloud Shell, which is a command line or a Linux or Unix based command line. You'll have notifications, you'll have settings and utilities, you'll have your profile. So as you can see, I've used my email ID to sign up for this account. And if you take a look at the projects, you can just see the project names over there. The number of projects which I have actually created are like 1, 2, 3, 4, and there is also a limit in the number of projects which you can create. So if I go into manage resources, you can see like no organization because I haven't attached any organization with this email ID. Have any G Suite subscriptions, as you can see over here. So there are two ways of doing it. The first one, like Google account or any email address, I've used that, and the next one is using cloud identity. Before going there, let me just go back into the console and I will show you like that's the resource management page. You can actually create projects. I'll come back into the project side in the coming lectures. We'll actually find out how we'll be using multiple projects for different environments like dev, staging and production. Meanwhile, let me actually log myself as my company user, and then I'll show you like how an organization and folders are structured in the project. Let me just check if that's the password. No. Alright, so I logged in now. Okay, let me just go and check. There you go. So that's the organization I have registered with the cloud identity, and these are all the projects and folders I have. Let me just go into the manage resources on this, and you can see like I'll be able to create multiple folders under my organization. So I have different folders for different countries, and I can create new project under that folder, so it's easy for me to keep track of each and every project used by different business around the world, or you can use it for different business in your location. You don't need to be if you're not an international organization. So this is how, and this is what is the difference between an cloud entity or G Suite based account being used for registering Google Cloud Platform and a normal Gmail account or your own email account being used for registering with the Google Cloud Platform. So we're going to go through the GCP resources or features we'll be using in our lab. So these are all the underlying infrastructure as a service features and resources available from GCP. This does not have the DevOps tool, which I'll be showing you in a different lecture. So these are all the resources we'll be using. The compute engine, which is like it has managed and unmanaged groups. I'll usually go with managed groups, where your VMs and your compute are managed fully by Google. In case something need to be patched or fixed or upgraded, or OS need to be upgraded, Google takes care of that fully. And if it's unmanaged, then you have all the responsibility to do that. I'm not saying like don't use unmanaged, but unmanaged is used for very less use cases. And next one is the app engine and GKE, the Kubernetes engine in Google, and Google Functions. So let's quickly go into the console and I'll show you a little bit of it. So if you take a look at how the web console looks like, there's a top bar which has a search bar, and there's an burger menu on the left. So we'll see the compute engine, which is like the app engine. We'll go into the dashboard. You can see like you have to first select a project. So let me just select this project. You'll see the welcome screen for app engine. So app engine is serverless service which is built on top of the compute engine, and you have actually pretty much most of the popular languages which can be used to create your applications. Like you can use Node.js, Java, Ruby, C#, Go, Python, or PHP. Fully managed, where you don't need to worry about provisioning compute engine or hardware behind the scenes, so it takes care of that quite automatically. And two of the powerful features which the app engine has is the application versioning, where whenever you do your CI/CD process and then deploy something into your app engine, it keeps the older versions, so you'll be able to quickly switch back into older version. And also another nice feature is the traffic splitting, where you can actually keep the older and new version and then split the traffic between that, and then do some A/B testing or blue-green deployment with app engine. Security wise, they have provided firewall where you can actually configure and then secure your application deployed in app engine. They provide managed SSL certificates by default with no additional cost, so it's quite secure. Your application is very secure in app engine. So what are the use cases for app engine? I would say like many of my customers, they use app engine for deploying web services. So it scales as the requirement actually goes up and scales down as the requirement comes down. So that's the main use case which I've seen app engine being used. You can also deploy front end into App Engine, so you can have your entire architecture completely deployed in App Engine itself. You don't need to go for any other feature or any other resources in Google Cloud Platform. Let's now quickly go into Compute Engine. So Compute Engine are the VMs. So these are the basics for any of the services or resources which you are going to use in Google Cloud. Everything is created on top of these VMs. For example, like if you are using App Engine, then that uses the VMs behind the scene. If you are using Google Kubernetes engine, then that uses the VMs behind the scene. So each pod will be associated with one VM in the Google Kubernetes engine. So here you can create your own VM instances. You can group them. You can have templates created, and then you can deploy the templates in the group. So groups are kind of fully managed or managed by Google using like manage instance group. So if I do a create instance group, it'll show like manage instance and unmanaged instance group. So you'll be able to create a manage instance group where auto healing, auto scaling, and auto upgrade, regional deployment, and load balancing are automatically done. Unmanaged is a group of existing VMs that you manage, that's like us who are going to actually deploy manage. So as I said before, managed instance is something which I usually recommend if you have a use case of using cloud compute engines with GCP. Very less use cases there for using unmanaged instances. I haven't come across anything yet. So you use instance template to create templates which gets deployed into the instance group, and then it can easily manage creation and destroying of the VM instances under managed instance groups. So this is kind of an base image or gold image which we'll be creating using the available boot disk, or you can use any container image or Docker images which you already created using your cloud build. There are other features which are there which I don't want to go deeper into it because this is not something which we'll be working on. So let me just go back into the menu and then we'll go to the next feature, which is like Kubernetes engine. So here is where you create the Kubernetes clusters, and when you start creating Kubernetes cluster, what I've done is I haven't enabled the API. So what GKE is, or what Google Cloud is doing, is going and enabling the GKE API automatically. So it will take some time. So let me just quickly go through on the menus on the left side. A cluster is where you create a Kubernetes cluster which will have a default node pool. So there it is. Let's click on create cluster and see what happens. Okay, so new cluster creation experience. So they've done that recently. So here you can see that you can provide the name of the cluster, you can create where you want the cluster to be. So if you want to be regional, you can actually select that, and then that will automatically create the clusters in different region, and then it can manage by itself. And what version of GKE you want to actually use, you can use the release channel or static version, and it always creates a default pool of nodes for you. So you have to have at least one default pool in a cluster. So everything has its own security, metadata, features attached to that. So you can have the kind of node which you want, as well as the security attached to the node, metadata attached to that, which is a part and parcel of the Kubernetes for managing the Kubernetes resources. And quickly we'll actually go through other features. Automation, so clusterable criteria for automatic maintenance and auto scaling and all, you'll be able to configure it here. Networking, so what's the network? So that's a default network which is created automatically when you sign up for Google Cloud Platform, and subnets, there's a set of default subnet also that's being created. Maximum pod nodes is 110. You can't actually go beyond 110 pods in GCP. I have no idea why they have that hard number for the number of pods. So that's the quick overview of the Kubernetes engine, or GKE, in Google Cloud Platform. You have other features in that, like for example applications. You can deploy applications from marketplace. There are some basic configuration. Once you create a cluster, you'll go through the configurations. And workloads, same, deploy, manage and scale containers on Kubernetes. Workloads, you can actually do that once your cluster is created. Service and ingress, you can actually manage how you will be accessing your services that's been deployed in Kubernetes. What are the use cases for Kubernetes? So you can very well do the same thing in other services provided by GCP, like App Engine or Cloud Run, quite easily without bothering about all the underlying infrastructure and underlying services. If you want full control over your deployments, or over what you've actually deployed into GCP, then go for Kubernetes engine. Otherwise, you can choose other options like App Engine or Cloud Run. So we'll now go to the Cloud Function. So Cloud Functions are smaller single-purpose functions which you create, which are lightweight and which are event-based and asynchronous, and which can actually perform certain duties for you. For example, you can actually say, like, if I get this message in the queue service, then do this task. So you can actually create a function. I'll just quickly show you what it is. So you can allocate a memory. So the trigger will be either HTTP or Cloud Pub Sub, which is the messaging service, cloud storage, Firestore, analytics, Firebase. So you can pretty much actually trigger based on all these aspects, and you can have an URL actually for that. So allow unauthorized invocation cannot be there. So you can actually upload a code. You can upload it from the cloud storage, and you can use different runtimes. Actually, you can use Go language, you can use Java, Node.js, or Python, or you can just type the code over there and then start using it. So that's a quick introduction on Cloud Function. Let me also go back and show you what Cloud Run is. So I have to actually enable that API now. So I'm going to enable that API. There you go. So when do you use Cloud Run? So Cloud Run is kind of an engine or a service which can run your Docker container and provides a HTTP endpoint for that. That's it. So throw any Docker container which has an HTTP endpoint in it, which is written in any language, then it will be able to create an HTTP endpoint for it, and will be able to use it right away. You can use it with custom domains. You can create rules, firewall rules and permissions and everything on top of that. App Engine, on the other hand, if you have applications written in specific languages which is supported by App Engine, like for example Go, PHP, Java, or Python, or Node.js, then you can use App Engine. So they have actually built App Engine to provide services for these languages, and they've tuned it for these languages. So coming back to our presentation, so what we have seen now is we have seen about identity and access management. We have seen about various GCP resources or functions and features available in GCP. And we've also looked at how the web console looks like and various compute engines or various options which we have for deploying our applications into Google Cloud. So thank you for listening to this long lecture, and I'll see you in the next lecture. And in the next lecture, I'll introduce you to the DevOps tools which is available in GCP. We'll go through each of them in the Cloud Console. You now may be wondering, like, is there any videos or any instructions available for how to install the gcloud command line, and how to install Terraform, or how to install the tools required into your Windows or Mac machine? Yes, we have that. Actually, I'll provide that as a separate chapter and lectures. You can actually look at those, and then you can help yourself to install the required tools in Windows and Mac.